Good afternoon, students. So in the last class we were discussing the total energy of an atom. So as we know that total energy of an atom is given by, it is the sum of kinetic energy and potential energy of the atom. I told you to simplify that. So just I tell you what answer you are going to get it. So total energy of the electron is equal to, it is kinetic energy plus potential energy. So what is the kinetic energy expression? In the last class we have seen that the kinetic energy expression is given by, it is Z square divided by 8 pi epsilon naught into Rn. It is given by, that is Z square divided by 8 pi epsilon naught into Rn. That is Z is atomic number, E is charge of electron, pi is constant, epsilon naught permittivity, it is also constant, R is the radius of the orbit. Okay, plus, so what is the potential energy expression? So we know that the potential energy is given by minus Z square divided by 4 pi epsilon naught into Rn. This is the expression for potential energy, that is minus Z square divided by 4 pi epsilon naught into Rn. So if you simplify this equation, take the LCM, simplify this equation. So if you simplify this equation, you are going to get it as, that is nothing but minus Z square divided by 4 pi epsilon naught into R suffix n. It is R suffix n, okay, nth orbit we are considering, therefore it becomes R suffix n, it is not R into n. So minus Z square divided by, sorry, it will not come 4, here it is 8. That is 8 pi epsilon naught into Rn. Just try yourself, try to simplify this, take out what is the common. After taking out common, you are left with 1 divided by 8 minus 1 divided by 4. So 1 divided by 8 minus 1 divided by 4. Take the LCM, simplify, you will get the answer as minus Z square divided by 8 pi epsilon naught into Rn. This is your total energy in terms of what? Radius. In terms of radius it is, you can take this expression by substituting the value of radius. In the last class we have seen what is the expression for radius. You will get radius R is equal to, so R is equal to, you have, that is nothing but Z square divided by, that is Z square divided by, you will get it like divided by pi m E square divided by Z. So that is your radius value. After substituting the value of radius, the total energy of the electron can also be written as, total energy is equal to, after substituting the value of Rn, simplify it and I will write the direct expression, that becomes minus m E square minus m e raised to 4 Z square whole divided by 8 pi epsilon naught h square, 8 epsilon naught h square into n square. So this is what, this is after substituting the value of R, that is, if you simplify you will get it as minus m e raised to 4 Z square 8 epsilon naught h square into n square, where n is nothing but what? It is 1, 2, 3, where n is nothing but, it is 1, 2, 3. M, mass of the electron, it is constant. E, charge of the electron is constant. Z, so for hydrogen, for helium, different atom, you can take the value of Z values, 8 pi, sorry, epsilon naught, then Z, H, it is Planck's constant, N is nothing but 1, 2, 3 and so on. So suppose if you substitute Z is equal to 1, that is for hydrogen atom, all the values are constant here, therefore energy of hydrogen atom is given by, this is energy, therefore I will write it as energy E is equal to, for hydrogen atom, if you simplify you will get it as minus 13.6 divided by n square electron volt. I am writing everything, I am substituting. For electron, what is the charge, what is the mass, Z value for hydrogen, n value I am keeping it as it is, n value I am keeping it as it is, other all constant terms substitute and simplify. For hydrogen atom, the energy of hydrogen atom is given by, that is minus 13.6 divided by n square electron volt. This is for hydrogen atom. Next what you can do, next you can take the value of n as 1, that is first orbit, n is equal to 2, second orbit, n is equal to 3, that is third orbit. You can take different values of n and you can calculate get the energy. We have seen radius, we have seen velocity, next we have seen that is total energy of the atom. So these all three derivations are important for 5 marks question. Any two or any one may come in the examination. Am I clear? So just go through the video. If you have any doubt, you can ask. Right? So next we have that is energy levels. Energy level diagram. By knowing the value of this E, you can draw energy level diagrams for different atoms here. So for hydrogen atom, what is the energy level diagram? Let us see. Okay, right. So here next concept is energy level diagram. So energy level diagram, how you can draw this for hydrogen atom? I will first draw, or first we can take with the expression that is energy E is equal to, it is minus 13.6 divided by n square. Suppose if I substitute n is equal to 1. Suppose if I substitute n is equal to 1, this becomes minus 13.6 divided by 1 square. That is nothing but what? Minus 13.6. This is first orbit. This is your first orbit. Then for second orbit, I can take it as minus 13.6 divided by 2 square. Because n is equal to, I am taking for 2. This is equal to 2 square, it is 4. So if you simplify this, you will get it as minus 3.4 electron volt. This is also electron volt. Then for the third. So like that you can calculate the values of energy. Then you can draw energy level diagram for the hydrogen atom. So here specifically we are studying for hydrogen atom. So let us see what is the diagram for this. So you have the value, remember the values. First 13.6 minus 13.6 minus 3.4. Then for third one you will get it as that is minus 1.51. Okay, like that you will get the values here. So let us see what is the diagram of that hydrogen atom. We will just consider n is equal to 1, that is minus 13.6. This is the ground level. This is the ground state of the hydrogen atom. Here you can write this is the ground state. This is the ground state of hydrogen atom. Then next we will go for the n is equal to 2. So here somewhere we can take n is equal to 2. So here something the value we got it as that is minus 3.4 electron volt. This is n is equal to 2. Then for n is equal to 3, here somewhere you can take n is equal to 3. That is minus 1.51 electron volt. So like that n is equal to 4, 5, 6, 7 you can consider. So this is what energy level diagram for hydrogen atom. So this is called as ground state. N is equal to 1. This is called as ground state. So here whatever you will consider n is equal to 2, 3, 4, 5, that is called as excited state. That is called as excited state. Right? So what is the conclusion of this energy level diagram? The hydrogen atom has only one electron and this is occurring in the ground state. Okay. Hydrogen atom has only one atom and this occupies the lowest level in the energy level diagram, and the lowest level in the energy level diagram is known as what? Ground state. Is known as what? Ground state. Suppose here what happens, whatever the hydrogen atom or the electron is there, this will absorb the energy. This will absorb the energy and it will get excited and it will jump to the higher energy level. The higher energy level here, that is n is equal to 2. It is called as what? Excited state. When it absorbs the energy, it is promoted to the higher energy level. This state is known as what? Excited state. This state is what? Excited required to bound the electron to the nucleus. That minimum energy is known as what? Ionization energy. So here that is three assumptions we can make by the energy level diagram. That is based on the ground state, and when it gets the energy it goes to the excited state, and in the excited state it becomes unstable. Then here it tries to leave the state here. Okay, so these are the three assumptions which you can make by the energy level diagram. Is it clear, students? First we have seen what is the total energy of the atom, and in that specially we have studied for the hydrogen. Then next we have studied energy level diagram. So what is the energy level diagram? For hydrogen atom we have studied this point, and one term we defined, that is called as ionization energy. That is called as ionization energy. Now in the previous class we have studied, that is Bohr atomic model. During Bohr atomic model we have seen one expression. We know that whatever atomic spectrum you are getting, it will be there in the different wavelength region. To calculate that wavelength we have expression 1 by lambda is equal to r into bracket, that is 1 by n1 square minus 1 divided by n2 square. How you will get this expression? That one let us derive. So what is our next derivation now? The expression for wavelength. We are deriving the expression for wavelength here. Okay, right. Okay, so our next concept is that is line spectrum of hydrogen atom. So what is line spectrum of hydrogen atom? In this we are deriving the expression for wavelength of a hydrogen atom. Specifyingly we are deriving for hydrogen atom. In general also you can study here. As we know that the electrons will jump from higher energy level to the lower energy level by giving a photon. In the assumptions or the postulates of Bohr's theory we have studied that E2 minus E1 is equal to h nu. I hope you remember this one. According to Bohr's postulate, the electrons will jump from higher energy level to the lower energy level by releasing the energy of a photon, that is given by h into nu. So that is higher energy level. Here I can write it as En2. This is your second level. Then the expression of energy is given by minus mz square e raised to 4 divided by 8 epsilon naught n square into h square. So for second orbit this will be n2. Similarly you write it for n1. Therefore it is En1 is equal to minus z square e raised to 4 divided by 8 epsilon naught n1 square h square. According to Bohr's postulate, we can write it as En2 minus En1 is equal to h nu. Right? So just substitute the value here. So what we can write? That is nothing but, okay. So substitute the values. N2 value minus m z raised to square e raised to 4 by 8 epsilon naught n2 square h square minus. So here what happens? So minus is there. You can also rearrange the term and you can also write it as n1 minus n2. कैसे भी लिख सकते हो. पहले इसको लिखेंगे हम लोग. That is minus m z square e raised to 4 divided by 8 epsilon naught n1 square h square is equal to h into nu. Correct? So here you can see that, see, everything is common in both the terms except your n1 and n2 value. See the expression. M, Z, E, 8 epsilon h, everything is common. So you can take out common inside the bracket. You can write it as. So what I can write it as? I'll just simplify and I'll write it as, that is mu is equal to. That is mu is equal to. First I'll take common. Better I'll go for common term here. So common is nothing but m z square e raised to 4. M z square e raised to 4 divided by 8 epsilon naught h square inside the bracket. Here you see minus into minus, it becomes plus. So what I do, this 1 divided by n, I write it first. 1 divided by n1 square, this minus 1 divided by n2 square. ये समझ में आया सबको? माइनस इंटू माइनस क्या होता है? transfer here. If I transfer this h here, this becomes what? H cube. I hope here it is visible. So this I can write it as m z square e raised to 4 divided by 8 epsilon naught h cube is equal to, this is 1 divided by n1 square minus 1 divided by n2 square is equal to only nu. We have only nu here, right? Okay. So what we can do now? We know that according to your first year concept, that is C is equal to, we know that C is equal to nu into lambda. You have studied this, the relation between velocity, frequency and lambda. It is given by C is equal to nu into, that is lambda. So here what I can do, I can substitute the value of V or nu from this expression, because I want lambda is equal to, मतलब क्या करोगे आप लोग, ये इक्वेशन को ऐसे ही रखोगे. So I can write it as, that is substitute the value of V in this equation. So after substituting, what you will get it as how you can do, इसको इधर लिख देंगे. This becomes 1 divided by lambda. Okay, this is nu divided by C, which is equal to, nu का value substitute करोगे, C will be in the denominator itself. So therefore you will get it as m z square e raised to 4 divided by 8 epsilon naught h cube ac वैसे ही रहेगा. करेक्ट है, समझ में आ रहा है? Into bracket what you have, 1 divided by n1 square minus 1 divided by n2 square. So I have just substituted the value of nu here, and this C I have kept it as it is. So that is, you are getting 1 divided by lambda is equal to, this all constant terms into bracket, 1 divided by n1 square minus 1 divided by n2 square. Okay students, so this is the last step here. Just see m, mass of the electron, z, atomic number, then e is nothing but what? Charge of the electron, 8 epsilon naught h, Planck's constant, c, velocity of light in the vacuum. This entire term is constant. That entire term I take it as r into bracket 1 divided by n1 square minus 1 divided by n2 square, that is 1 divided by lambda is equal to. So this is the expression for wavelength, where r is known as Rydberg constant. Already we have discussed in the last class. The constant value is 1.09 into 10 to 7 per meter. So as you have studied already, for different atom, in the sense, that is for what atom, that is for this you can say series, Lyman series, Balmer series, Paschen, Pfund, bracket, this n1 n2 value, how it will change, that we have already discussed in the previous classes, right? So this is the expression for your lambda is equal to. So this whatever reciprocal of lambda is there, that is known as wave number. The reciprocal of lambda is known as wave number. This 1 by lambda is known as wave number, denoted by mu bar. It is denoted by mu bar here. This is known as wave number. Right? So please go through this video and see the derivation. Very simple but very complicated, because here just we are simplifying the terms. ये E1 लिखना है आपको, E2 लिखना है, सब्सट्रैक्ट करते जाना है, कॉमन टर्म्स बाहर लेना है, just to simplify. Only you should remember one equation and second equation. If you remember these two equations, other things are only simplification. Can you see this properly? Only simplification I have done. Nothing is there physics here. Only equations. This and this is physics. बाकी का सब कुछ हम mathematical simplification कर रहे हैं. So here 1 by lambda is equal to, you will get the expression. This 1 by lambda is nothing but it is wave number. That is reciprocal of wavelength is also called as wave number. So this is the expression for wavelength. For different series of spectrum, we have n1 n2 values are different. 1, 2, 3, 4 like that we will take. So this is regarding the line spectrum of hydrogen atom. Therefore, we have taken Z is equal to 1 here because it is hydrogen atom specifically we have studied. Is it clear everyone? Okay, please go through this video and see, and we need one more class to finish this atom chapter, then we can go for nuclei.